This is Old Electronics Fan, and this is part 3 of this series on the Sony stereo, the STR 6050. And I wasn't going to make this video because initially I didn't want to investigate the weird problem I was having here. Number one is, well, let me show you what the feature is, and then I'll explain to you why, well, you'll see. Alright, so this is the mode switch. If you turn the knob that way, you can reverse your left and right channels. This is back to stereo and normal. Put it here, there's an L plus R. That puts the left and right channels together as mono. Then you go, oh, come on, I think the fingers are sliding. That says left, and that says right. Now what's supposed to happen on these is, if it's on right, the right channel is the only one that should play. If it's on left, the left is the only the left is the only channel that's supposed to play. That is not what is happening with this. And so, as you can see, this left-right function it's not something that you would use a lot or ever. So I was thinking, well, should I bother looking into it, because I'm never going to use it, probably no one else will either. Is it worth doing? But my curiosity got the better of me. Plus, as I've gone through this, I realized there are a number of mistakes that I made, and I overrode my tendency to remove all videos regarding the stereo, and instead I wanted to post this one to address the mistakes I made, and maybe if I do this enough, remind myself to slow down and pay attention, I won't make mistakes like this. But there are things I want to correct about, there are things I said in my previous videos on this that I really want to fix. And there were definitely some mistakes made. Well, I'm bringing you here to a simplified schematic to make it easier to see how this is supposed to work. But yeah, I am going to show you this, but I am feeling pretty stupid right about now. Each time I look at this, I discover one more thing that I've overlooked or didn't think about or didn't make sense of. And I'm trying to understand it because I want to not do it in the future. Here's my thinking, kind of. It's not a good excuse, but here's what it is. Now this is how it's supposed to be wired. Let me just actually show you. Yeah. I wired it differently because there are two things. Number one, I made the assumption that, I'll go back here. I made the assumption that there should be a resistor in series with these two pins. Well, there actually was. There was a resistor here, 470K, and one here, 470K. It was already there. I missed these two resistors, but I was looking at what was in the stereo. I missed some of this because it's very hard to read. I should have enlarged it on my computer. I had it there. I didn't do that. But that's all irrelevant, because let's take a look at this. Now this is supposed to be a complete wire, just in case you don't know. Alright, for any who don't know, this is a DIN connection. And let me just bring this up a little bit. This was popular, or well, this was used early on, especially with phonos, and I think tape players, maybe some other things as well. And you don't see it very much anymore. This one company that makes equipment with these, they favor it. They think it's the right way to go. A lot of other people disagree and say no, 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 no. RCA jacks are good, and they work great, and you don't have to worry about it. I kind of agree with that position. But so the other thing I did wrong was I thought the person who owned the stereo had rewired this and done so incorrectly. So my mindset was he rewired it, he did it wrong. That's the problem. I need to fix that. And as I look at this, I feel how totally stupid that was. And let me explain a couple of reasons why that thinking was absolutely foolish. This right here is this ground. The idea, and this is the amp, the little, call it preamp, EQ amp, whatever you want to call it. They call it EQ amp. This little amp has inputs coming into it, and then it feeds out here and here. This goes back here to the record RCA jack, left and right, out, out. But it also feeds forward to this mode switch, which then ultimately feeds into the volume controls, which then feed into the amp, the main amp of this setup. Now, the L position and the R position on the mode switch, what they're supposed to do is they're supposed to open up the connection between here and here on one side or the other. That's why I simplified, this is a switch symbol that I stuck in here just to make it simpler. Than didn't want to go into all the details, at least not yet. I'm going to show you me troubleshooting this, but I want to go over this and explain. I still can't comprehend that I got this so completely wrong. But anyway, I made two assumptions that I should not have made. Number one, well, actually it wasn't wrong. There's a 470k ohm and a 470k ohm that are indeed in series with this connection. That's what I expected there to be. When I saw them in series, I don't know why I didn't have aha, there's those resistors I expected to see here. Don't know. I got myself totally screwed up. But all of that really doesn't amount to anything because I want to just, well, here it is. So let's pretend that this switch is open so that the signal can't get to here. It can only get to here. This output can't go here. Can it go here? No, it cannot. There is no connection through this connector. Even if you have something connected to it, the signal can't cross this connection. The circuitry in the device that's attached typically won't allow that. They're designed to keep the two stereo channels separate, because this is one stereo channel, record out right, and this is the other side, record out left. And so why wouldn't the signal be able to go back through here, even apart from the values of the resistances? Common ground. The signal would come out, it would hit ground, and that's it, it would stop. This would go to from whatever voltage. So if you were to put a meter across from here to here, you'd get, well, I'm not sure what kind of a voltage drop you would get because I don't know what the current is. Oh, and let me mention this. When you're dealing with consumer grade audio equipment, line level voltages are typically around 300, 330 millivolts, something like that. If you're dealing with pro equipment, it's 1.3 volts, somewhere around there. So you're not dealing with high voltage. But even so, if you've had 100 volts on here, if I put a meter here, negative here and plus here, I would measure the full voltage drop. That 100 volts coming out of here would be dropped across these because this is ground. There wouldn't be anything left. This would be 0 volts, 0 signal. at this point. There's no way in the world for that to go here and then go here and go through this. I'm feeling pretty stupid because that's obvious. I don't know what I was thinking. I don't know why I thought somehow that could travel through here. This would prevent it. It would stop it, absolutely stop it. The guy who criticized me was absolutely right. That was stupid. And I just don't understand why. I should know better. I've been doing this a very long time. I don't know what happened to my thinking processes, but there's no way in the world that this will get over there. And even if it did, let's just say on some crazy, maybe you had a bad ground here. Let's just say somehow you went through almost, well, this is actually probably about a megohm, because this is 940 plus 164. So you're talking a megohm of resistance total here. So say this could travel out here, go through this, come that. By the time you got to this point, that signal would be pretty weak. But here's the important part of all this. It doesn't matter. It absolutely does not matter. Whether this can go through here or not, it absolutely does not matter. Because what is the symptom that I'm experiencing? The symptom I'm experiencing is that even with these switches in the correct position, I'm still getting both channels. I'm getting I'm getting audio out of the left side and out of the right side, and they are at the same volume. I really, really, really wish I had stopped to think about that. The fact that the volume of the signal here and the signal here were apparently equal means that none of this had anything to do with it. Absolutely nothing to do with it. So even if the signal could somehow get through this mess, which it can't, by the time it hit here, it would be very low, and it would be on one side only. Now that I see that, I feel like, where was your brain when you were figuring this out? I'm not happy. I'm not happy at all. I feel like I left my brain behind when I was working on this. And the person who was criticizing me, he was absolutely right. He could read the schematic. He knew how this was supposed to be, and he knew that what I was saying was absolutely dumb. So I don't, how do I put it? I am presenting this, even though it makes me look bad, because I don't want to hide the fact that I really royally screwed up in troubleshooting this. I mean, I absolutely, completely, royally screwed up. I hope, and the other thing is that if I humiliate myself, hopefully next time I will think about what I'm looking at. I will evaluate the circuit, evaluate the possibility of the circuit doing what I'm thinking it might be able to do, and realizing that says no. And also realizing if this is open, you get one channel, which is what you want anyhow. So it doesn't matter if this leaks through there. It's just not possible. So my brain waves, or my mindset of, he changed this, he changed it in the way that caused this problem, the fault is here. That was probably my downfall right there, thinking like that, instead of stopping and thinking, well, does what I'm thinking make sense? Does it really make sense? And this absolutely does not. Wish I had seen that a little bit sooner. So, what I'm going to do now is I'm going to put in, I'm going to show you some troubleshooting I did on these switches. Because I think I got that part right. Okay, interruptions. But anyway, so I've got to look at, so pin 6 and 9, so there's There's pin 6. And there is 9 right there. So those two and those two are what I need to look at, because that's what matters in terms of figuring out whether or not this part is working right or not. So I'm going to move over here. We'll look here on the stereo. I must be having a brain fade because I had this all figured out, but I'm not going to go any deeper than that because that's all I really need to get into. And yeah, anyway, so let's come over here. Where are you? There you are. Focus, please. And we're going to come to here. All right, now, one of the things that enabled me to sort this out, or writing out the color codes, chasing things out, figuring things out, got me to the point where I kind of know my way around this now. So this is one of the volume feeds, and this white wire is one of the other feeds for the volume. So, and I guess I'm going to have to back out a little bit because I'm not going to be able to do both here if I don't do that. Yeah, let's see if we can. Alright, and do this. Now, what I want to do is see if, yes, alright. So I'm going to hook this onto, I put this on there, and I guess I don't really need this. Now, where do I have my control? I don't know. Okay, it's all the way to the right. So, okay, so that tells me the connection between here and here is being made. And now I switch this and turn that way, and I connect up here, and I go there. And if I go here, I have high ohms. And then I'll go back here because I don't think I did that. And turn that way. And so if I go here, high ohms. So that appears to be working just fine. And yet when I play this, I don't get the it doesn't behave the way it's supposed to behave there. And I even took a audio signal tracer, and it doesn't matter where I put that control, those two, the L and R positions. I get signal here and here for both positions, and I get it everywhere in here. So, but you see what the meter's telling me. It's telling me that all is well. And I spent some time looking over the schematic to see what I'm missing, to see what's going wrong, or what's gone wrong. And a bit baffled, actually. But, so I've checked between here and here and here and here and here and here. That seems normal. But I'm still getting signal on both channels. Because what's happening is one of these is supposed to be disconnected from those, one of those. This is where the signal's coming in. This is where it's going to. Signal in, volume control connection, volume control connection. So, and so I've looked this over. I've looked at the wiring. I looked to see if there's anything at all that might indicate that I've got this, or that it's somehow wired wrong, and I don't see it. But actually, there's something I didn't try. Well, let's see. This is the one I've checked every which way with my meters except this way. All right. That's no good. I've connected across, these are the left and right volume control connections. I should not have a short between those two. So what's going on? Yeah, okay, so that's L and R I'm switching between. Now this is the L plus R, which is the mono. And I go here, and lo and behold, oy, oy, oy. Interesting. Why? I understand the L and R because it's mono is grabbing both channels. I can understand why that would happen. So why? That's not supposed to be. Yeah. It's not supposed to be possible. That's not good. Why is that doing that? Well, I guess I found out what's going on. Interesting. Aye. How can I? Yeah. There's that. I don't understand. And how is that happening? Yeah. Well, I've got one of two ways I can look at this more in depth. I can take these two nuts off and pull this off and look at it. Not crazy about that idea because I'm pretty sure the screws are going to give me fits when I try to put it back together. And I'm not sure if I do that what that's going to do. It's got a detent assembly that allows it to clip the way it's supposed to. The other thing is take this front panel off, take this out, and look. Well, let's look at this because I didn't look there either. Let's see. Well, if those two are shorted together, then these should be. Which that's puzzling because when I was measuring from here to there and there, I wasn't getting a short. And I'm not getting a short there. Interesting. Well, what that tells me is that something in this switch is shorting this to this. And at the same time, it's not tying these two together. Now, if I had thought, yeah. Okay. Here's what I see, or what I'm thinking. Because these two are getting tied together, it doesn't matter whether the signal comes here or the signal comes from here. Both channels are going to get that signal. And based on what I saw, these connections are being disconnected the way they're supposed to be. On the other hand, this isn't. Really? Yikes. Yikes. Let's see. Why? If I want to find out about this, I think I have only one choice. And that is Yeah. I need to see what's going on in the back of this. I really do. And so I think the only way to do that is to take it apart. Now that I've figured out what's going on, now I have to ask myself, is it worth all that work? And I'm not sure. Well, I don't even want to tell you how much time I've spent on this. I was absolutely determined to find it, and I did. I don't understand why I found what I found. Doesn't make any sense, but let me see if I can zoom in here. And hopefully, I was going to try to get a little microscope camera on here, but I realized it just wasn't going to work very well. Now, so we'll have to make do with this. This is the left-hand volume control wire. This goes to the right-hand monitor switch, and there's actually two connections from each of the monitor. Well, there's two monitor switches. Well, no, there's. Let me back up. One monitor switch, but of course, half of the monitor switch is for one side, one side of the stereo channel, and the left side, and the other half is for the right side. If I could talk, it'd be a wonderful thing. So, what that means is, let me go back here. Let me show you on here, because then it hopefully makes more sense. All right. This is a monitor switch. There's another one down here. Let me use this one, because I think it's clear once I show you this. In fact, let's zip in there a little bit more. Yes. All right. This is the output from the amp. This line right here that you see, and that's supposed to be orange. My camera says it's brown. It lies. But anyway. So that's one source of signal from the amp. Now, this is the monitor control. Like I said, one here, one down there. You notice this wire branches off to the monitor switch. And in its current position, it feeds the output from this amp to this switch. So we've got this goes over here and feeds over here and goes down to there. This goes over here and it feeds into this switch, and it feeds into this switch. What it amounts to is that you have two different connections per channel, where you can get an output from from the amp. Basically, they just split the wire into two different directions here, so that they can feed different parts of these switches separately. So, this was really, this is also fun. If you notice that I've darkened that, put a little arrow that goes in further. The diagram that this is, and I should look, I have two service manuals I downloaded. I have to look to see if the other one has this error. Go over here, I don't know if you can see it, on pin 9 right there where my pointer is. The arrow goes out further. If you go over here, notice that the arrow is shorter. Well, this is on this part of the wiper all the time. It's never disconnected. This inner ring, that connection always wipes that. The same is true of this, but it was not drawn that way. That's why when I went to try to explain to you about this connection and that connection and why this should all work, and yet it didn't, because according to the way this was drawn, the minute you turn the switch so that it connected only here, this was disconnected, and this was kind of important because this goes to the volume control. So how, and this is the only way to get signal into the rest of the system. So how was that working? I knew it was working, but how was it? Well, by taking that switch off and looking it over, it took me a while to find it. I found out that this was not drawn correctly, and that this always, just like this other connection over here, this always has a connection to this ring. So no matter where I swing this, this always has a way to feed audio into this switch. And depending on what you're looking at, because pin 7 and pin 7 are the front and back sides of the same thing. So even though they don't show a connection here for 7, there is a connection to 7 over here. It's the same pin. It's just, this is the front of the switch, this is the rear of the switch. It's just been very challenging. So let me show you though what I found, and I'll tell you, if somebody can explain this to me, I would love it. So where are we? There we are, kind of. Alright, now let me identify what we got here. Over here we have red. That is the right hand volume control. Over here, this is the left hand volume control connection. And this is one of the amp outputs, and this one happens to be left hand. So that makes sense. So left hand volume control, left hand amp connection. Great. And if I put my meter, let's put it on noisemaker, and then I don't have to try to get it to fit into the screen. Alright, so I do that, and I do that, great, and of course I've got this. However, what is not great is that this, because this is here, this part right here connects this to this, effectively shorting the two volume connections together, volume control. Left side, right side, shorted together through this. If I were to remove this wire, I haven't even explored that, but I can't do that because there's reasons for this to be there, and I don't understand. So there's two mistakes as far as I can see. Number one is they didn't tell me, this is pin 6 I believe, yes, on the drawing, well I can't show you both, on the drawing this is not supposed to be connected always. This one is, kind of makes sense that that one is, but it was not drawn that way in the diagram. That means that because this is connected to this ring, and this connection, so this is always, this right here is always connected to this ring. This ring is now connected to this, which actually doesn't make sense because I've got this all the way to the right. So theoretically, yeah, theoretically I shouldn't have a connection, well, this connection shouldn't be there. Because this should be, am I right? Or am I losing my mind again? No. That's the right. What happens if I do this? Yeah. Let me see. Yeah, okay. So we've got the same problem. This wire is connected to this internal ring, which this is always connected to. And because of that, because this has been selected to make the right amp work, is that right? This seems to be backwards as well. I'm not even going to go there. Spent way too much time on this. So what's happening is there are connections in this switch that will never allow this to behave the way the manual says it should. It just won't happen. I don't understand it, but this switch, the way it's set up and the way it's wired, it is always, always, always going to provide signal to, meter off. It's always going to try and provide signal to both channels, no matter whether it's set to R or set to L. And so I really don't have a clue. I mean, I don't know if this print is part of Y, or if something else is going on, but the bottom line is I will never fix this. And I really didn't entirely want to get into this, but I just felt like I had to, because I really wanted to know what was going on. And I've done so much work, and let me just show you a little bit of what I've drawn up to try to figure out, try to make sure that I didn't have to keep figuring it out each time I looked at the different color codes. I told myself what each color code was, what it went to, what pin it went to, and finally, after writing that out, and I had this here, but that wasn't giving me everything, because I had left and right, pin 1 and 2. But this gives me the color code and what it was for and the whole thing. And then finding this little thing, that was the end of the road. Finding this typo, I don't know how they drew that wrong, but they did. And my meter tells me that that is so. I'm going to put this back together and call it done, because there's no fixing. I can't comprehend how a manufacturer like Sony could get this wrong. I mean, they might as well not have that feature based on how they've wired this thing. So, anyhow, well, I want to wrap up with this. I've definitely admitted that the commenter was correct in what he was saying about my evaluation of that circuit. He was definitely right. Still can't figure out, I can't comprehend I got it that far wrong. But I do disagree with him on his comment regarding the tuner. And let me just explain for anyone who doesn't know how these are set up. And let's get that over there. You can get it to, how about you focus, maybe? Focus? Alright. Yes, alright. Now, this is a basic tuning capacitor, and notice it's got ball bearings in there on one side. On the other, the shaft, this has a rounded tip, and it fits into a little indentation in the sidewall of this. And actually it's got an adjustment screw there to allow you to adjust this for the right tension. Now, this moving part. This part is connected to the frame. It seems obvious, but then you might ask, well, how do you make sure that this part, when it's moving, stays connected to the frame? And that's where this piece comes in. There's a little metal plate right there, and it's spring-loaded, and it's putting pressure on the side of this shaft, making sure that the moving part of the capacitor stays connected. So if you're connecting this up to something, you've got these two connections here, and I had them tied together for a project at one point. So So these two are connected to the fixed portion of this capacitor, and this is insulated from the frame. So if you connect one wire here, and then you connect one here for, say, the antenna, and then one wire here for the oscillator, and that's how that works. Now, what can go wrong with these? Well, over the years I've worked on a bunch of older radios, and I run into bent blades, I had one, it was in one of my pieces of test equipment, and I did a risky thing. There was a short between one of these blades and this, and I couldn't find it. So I threw fairly high voltage across this to try to get rid of the short, and it worked. But that was very risky because you could actually burn these ball bearings where they contact here, where they contact there. If you arced between the ball bearing, or between the shaft and the ball bearing, or between here and the ball bearing, you could wind up with a dead spot in your capacitor. So it really wasn't a good idea. I did not damage the tuning capacitor that time. So now what I do instead is I check with a meter to see if I have I hook a meter here and here across these 2 points, and as I rotate this, my meter is going to tell me if these are contacting, and I start looking, and sometimes I have to bend the blades a little bit and to get them so they aren't touching, because sometimes these things do get abused. Sometimes there's dust in between the blades, and those will cause static. The most common problem, though, has to do with this right here. This spring-loaded plate sometimes gets corrosion on it, and it seems weird, but as you rotate it, depending on where the corrosion has occurred on the shaft and on that plate, you'll either get static or you'll get dropouts. If you have that, if you experience that with your tuning capacitor, just spray that with a little bit of deoxide or something, some kind of contact cleaner, and then cycle it a few times to see if that solves your problem. Now, I've had these come in radios where they've been really abused, and the bearings would actually be rusty, or if there was grease in there, sometimes that would get really hard. So putting a few drops of lubricant in here is about the only thing you can do to try to get this freed up. And I'll usually, and depending on how it's working after I've done that part, if I feel that it's loosening up a little bit but it's still not right, then I'll put a drop of oil over here, which I don't know if you can see, but there's the end of that shaft goes through the opening in that little plate and goes into there. So I try to put a drop of oil down the frame into that contact point and make sure I can free it up. If I wind up with a little bit too much oil on here, then I might hit it again with contact cleaner, just lightly. And usually, and there's different kinds of contact cleaners. Some of them have a lubricant in them, some don't. I've got one that I use for wafer switches because it leaves no residue, and that avoids the problem of possibly getting carbon tracking happening, especially a wafer switch that's dealing with line voltage. That's one of the times you'll get them to carbon track. So when I was working on this, I did lubricate here and here and in here and in this shaft right here, because it was all gummed up, it wasn't working right. And I think I did because I wasn't paying attention. I dropped a little bit of oil on one of these, which is not great. But one of the things that you can use a contact cleaner. I have one from WD-40 that's non-residue, but it's also acts pretty good as a degreaser of sorts. So if I make that mistake, then I will spray this contact with the contact cleaner. If the problem still persists, then I'll go with something like deoxit and hit that again. And sometimes you have to hit the connections more than once. So I've had to. Then I don't know how many times I've had to do this, but there have been enough times when I've been rotating a tuning capacitor, and it would experience those things. So one of the first things I try to do, especially if you open this up and you see all kinds of dust in here, I'll get my canned air and I'll spray it out and try to get it cleaned out. In fact, when I was cleaning the dust off from this, some of the dust actually did deposit on the capacitor, and I had already cleaned it thoroughly and had gotten rid of all the static, but then when I was using it after cleaning the dust out of it, it started staticking again. So I knew immediately what the problem was. So I went at it with some canned air and cycled it a few times, and the problem went away. So those are those are what I do to deal with tuning capacitors that are giving me fits. I don't know why that fellow thought I was destroying the tuning capacitor. I've repaired a goodly number of these, and I haven't had them fail or do anything bad. I mean, it's really not nice when you have a tuning capacitor that's just so stiff you can barely use it. I mean, you have to do something with it. You have to lubricate it. And I've had some where they were not good. And I've got radios that I repaired years ago, the same way I did this one, and to date I've not had any problems with anything as a result of doing that. And well, yeah, this one has a little screw there as well. I wouldn't mess with that screw. I don't know if they use a locking agent or something, but they would have to do something like that, because if they didn't, the constant pressure of rotating this would try to loosen that screw up on them. Now, I've never had one do that, so they must have locked them in there pretty good. So a stiff tuning capacitor usually can be cleared up by proper lubrication, contact cleaner in these parts, lubricating the bearings. That's usually all it takes to free them up and get them to start working properly. So, like I said, I haven't had any trouble. I mean, I've been doing this for years, and I've not seen any problems. If you think I'm doing something wrong, I would definitely like an explanation, because as I've proven, I make mistakes. So I think I'm doing it right by treating these capacitors the way I'm doing them. Like I said, I've been doing this for a lot of years without any trouble. So, but I just wanted to mention that, number one, if you have problems with for your radio and you're getting static when you're tuning, this is usually your culprit. This is definitely weird. I have reached the end of the road as far as what I want to do with this. I was determined. At first I wasn't going to, because like I said, who uses that feature? Not too many people, if any. So let me get this back out of here. But I felt like I was just not completing the job. And I wanted to know, I really did want to know why it was doing it, and if there was any way to fix it. because I like to have all the functions working properly if I can, and this one obviously didn't. So here's where I'm at. I've got so much time invested in this, and you can see some of what I did: color codes and charts and tracing and checking and taking it apart. And I've reached the point where I don't want to invest any more time in this. I think there's diminishing return on that going any further with this. And for most people, it's going to stay on stereo, and that's it. This control will never get used. Alright, so I am wrapping up. Well, I hope that you liked it. I've accomplished what I wanted to. I'm going to wrap up right here. I know what's going on now. That makes me feel good. And on the plus side, bear with me just for a minute. On the plus side, I learned. I was able to correct my misunderstanding of something, which I still can't comprehend how I did that. It's just beyond my understanding. But it is what it is. So yeah, so that's it. Thank you for watching. Hopefully you enjoyed this. Hopefully you got something out of it. Like I said, I'm posting this video to let everyone know what I got wrong and let them know what the solution was to this mystery, or at least what's causing the mystery behavior. So, alright, hopefully I'll see you guys watching the next video I do, whatever that is, and like, subscribe, all that would be great. Thanks.